Hi everyone, this is Shaunak, and today I'll be talking about staging e-commerce products for online advertising using retrieval-assisted image generation. This is joint work with Yuning, Misha, and Paloma when we were all together at Yahoo. So with that, let me get started with the setup. So our setup is that of an e-commerce vendor working with an advertising platform to show their products to online users. A good example of that would be like imagine there's a publisher which has a website on like top five home decor ideas, and the website the page has some organic content. As you can see, like there's a nice sofa in a living room, and the advertising platform's job is to figure out that hey, this is a nice placement to insert this ad about the sofa product that the e-commerce vendor is selling. As you can see here, there's no background around the sofa, and imagine you had a background, like there was a natural, nicely decorated living room around the sofa. Such a staged image or a lifestyle image, as we call, it blends well with the organic content of the page, and it's known to drive better user engagement as opposed to having a blank background. So with that value of a staged background in mind, let's see like what's the challenge in like scaling it to all the products in an e-commerce vendor's catalog. So it is expensive to first of all like stage these products physically, and secondly it's a time taking process, and scaling it to a million or even a few thousand products might be time consuming. So we at this point we thought, how can generative AI help? Like, can we even generate the background around this product and help the e-commerce vendor scale? With this motivation in mind, we studied multiple tasks in our paper on staged background generation. And the first task that we studied is something we call vanilla staging, where you have a product, there's no background, and the model or the generative model has to generate the entire background around the product. We studied a simpler variation of task one as well, which we call copy paste staging, where there is a input product without any staging, but there are other images with similar products which are staged. And the idea there is to like figure out a way to have a stage background for the input product which does not have a stage. In addition, there was another task that we studied, and we think of it as a bonus task because it came as a nice side benefit of studying like tasks one and two, and it's on like generating an animation from an image. So with this, let's get started with task one and two, and I'll cover task three towards the end. So task one, as I just described, it's to generate the entire background around a product. And in this paper, we we do it via a model called pix2pix. Pix2pix can be thought of as a black box, which is a conditional GAN, and this is a very popular approach for image translation tasks. In our setup, in particular, we used it in the following manner. We took ground truth images, which is this middle column here that you can see. Like there's a sofa in a nice living room. There's a bed in a nicely decorated bedroom. And we took this input image and we stripped off the background to create these images that you see on the left side. So given such an input image, the pix2pix model was trained to generate the background around it. Because we already know the ground truth, it is how we pose it as a generation problem, and taught the model how to generate the background. But as you can see in these examples, the model is not perfect. It hallucinates. I mean, there's a large surface area over which it has to generate, and it does mistakes. And this was the motivation of studying task two, which we call copy paste staging. The core idea in the copy paste staging approach is, imagine you have a sofa, this brown sofa on the left, which has a staged background, and like someone put in the time and money to create this background. But there's a red sofa, the sofa on the right, which does not have a background. And the idea is, hey, can we remove the brown sofa from this background? Just copy the red sofa. That will still expose some regions which were covered by the brown sofa, but I mean, the red sofa cannot cover it the way we placed it. So there is still a generation task that needs to be solved, and that is of like filling these white spaces to gel well with the original background. This is the core idea, and we can imagine a workflow coming out of it, which will lead to the final generated images. So in the setup, we need a pool of staged images, which have some products and which are staged nicely, and an input is a unstaged product image. For example, the sofa one image that you can see here. So given sofa one, the first task that we need to do is like retrieve similar sofas, like similar product images from the pool of staged images. And we used a lightweight approach using Inception v3 embeddings. So you can imagine that there's a sofa two which gets pulled. Now, from the sofa 2 image, we will remove the sofa 2, the main product in the image. And then in the next step, we inpaint the empty mask that is formed after product removal. And then finally, we will copy back sofa 1 onto this image, which was derived from sofa 2. So that's how the workflow looks like. And this idea of like first retrieving similar images and then like doing in painting is loosely inspired from like the success of retrieval augmented generation in text generation setup, where like the retrieved information is helpful to make the model understand the context. Uh, so with that, the other important component in this workflow is that of in-painting, and let me talk a bit about it. So image in-painting is the task of reconstructing missing regions in an image. And there's a model called Edge Connect that we leveraged. Edge Connect is based on like generating edges and then generating the color and texture. So it does it in two phases. There is a way in which we adapted Edge Connect for our setup, and what we did was we modified the loss function in a very specific manner, and that I can explain through these images. So imagine this ground truth, as I've shown on the left side. For training Edge Connect, the default method is to like create this white spaces or free form masks, as they say, and then ask the model to in-paint it. What we did as what we did differently in our setup is we created these masks, but then we changed the loss function to focus more on the boundaries, because our motivation was like, hey, we want to in-paint the holes left by removing products, and we really want to be good at the boundaries where the product was removed. So with this motivation or with this setup, let me show you some examples which will give you a visual feel of how copy-paste staging works. So there's a sofa on the left side that you can see. That's our input image. And we use data from Yahoo to get similar sofas which were staged. And you can see like 3 examples here. And then we removed the original product and we copied back this input sofa. The 3 images in the bottom row, they show the parts which have been in painted. So these green regions that you can see are, there were white spaces left after we removed the original product. And you can see like the in painting model does a great job of like in painting it back so that it looks part of the, it blends well with the original image. There are some bad examples that we saw in copy paste staging as well. Like for example, in the case of this table, if you look at this middle image, the in painted region is not looking great, and the main object that we copied back is not able to hide this mistakes in the in painting model. So this is not a great example. But the other 2 images that you can see, the left one and the rightmost one, they in that case, the model seems to have done a better job. We also had some quantitative evaluation. So we had an audit team, and the auditors were given 100 samples each for like 3 tasks, and the 3 tasks are as explained in this table. The first task is to compare vanilla staging versus ground truth, and as expected, we like in none of the vanilla staging cases the generated image was better than ground truth. That's expected. In the second task, we saw that 3% of the images, in 3% of the samples, the copy paste staging approach led to a better result than the ground truth image. So maybe it came up with a better background than in the original ground truth image. And then finally, which is the key takeaway in this paper, copy paste staging leads to better results than vanilla staging. And you can see like 76% of the samples were such that copy paste staging was better than vanilla staging. So I would say that's the main result in this paper. We also evaluated something called FID, which measures the feature distribution between the target domain and the generated domain. Smaller FID is better, and the results align with that of human evaluation here. Like after using Edge Connect with weighted boundary loss, we see a lower FID score. So I also talked about a bonus task in the initial portion of the talk, and it's now time for that bonus part. The idea here was because we have a way to in Paint, it leads to a way to generate videos as well. And let me explain it through these images. So on the left side, you see the original image with a background which may be staged physically or maybe generated through the approaches I described. If we extract this main sofa and we move it a little bit, as you can see, like I moved horizontally towards the right, there is a white space left because of this movement. And since we can in Paint, we can fill this, and then the sequence of images, like the original one and the in painted one, kind of looks like a video, as I'll show here. So you can see that there's a movement there. Cool. So this is a pretty cool application of using in painting to generate videos in our setup. With this, let's move to the conclusions. So we talked about 3 tasks, and we showed that copy-paste staging is better than vanilla staging. There's room for improvement in terms of hallucinations and also generating images which are consistent with the shadows and the lighting in the image that we copy from. And finally, although we shared results in a GAN-based setup, and recently, like stable diffusion models have really taken the limelight. But these ideas, these retrieval-based ideas, can be easily extended to those setups. With this, I end my talk. Thank you for listening.